Hello folks, welcome to my channel Code with Infinite. In this tutorial, you learn about how JVM works, or I can say you learn about the internal working of JVM. So without a further ado, let's get started. This is our first Java code that we have written earlier and executed it, and we got an output as hello infinite. So this Java code in front of you is a source code. Any code that is written in a .java file is called as a source code. Now this source code, how does it gives you output? You have a source code, right, which is like this. It is compiled with the help of a Java compiler to convert that code into a byte code, right. The byte code is nothing but code which are present inside a dot class file. Now this byte code, it cannot be understood by something called as machine, and it cannot give you an output. So we require something in between so that we get an output out of this byte code. So for that JVM will help you out. So this byte code is given to JVM, right. Now JVM does what is, it will look for the main method in your program and starts the execution and give you output. So is it that simple? No, a lot is happening behind the scene when you just get an output of your Java source code. First is what JVM does is, the byte code that you have given to JVM, it converts it to native code, or you can say machine code, which is in the form of 0 and 1, which machines can understand, and then only you get an output. So is it that simple? No, there is a lot happening inside this JVM. So what is happening inside the JVM that you get a output? So let's understand behind the scene what is happening inside the JVM. So to understand what is happening inside the JVM, we will understand the architecture of JVM. In JVM, you have different, I can say something called as modules or layers, or you can say steps. So first one is the class loader. The byte code is given to this class loader inside the JVM. The second layer is JVM memory. In JVM, inside JVM, you have different types of memory for different purposes. First is method area, second is heap, then we have stack, PC registers, native stack methods. Then we have the third layer or the bottom layer. In that we have execution engine, then we have native method interface and native method libraries. So all the modules that you are seeing on the yellow will be learning as part of this course, and all of them that you are seeing as red ones, that you will learn when you will see one of the advanced concept, that is something called as threads. So these modules which are marked in red, right, it will be used by threads in Java. So once you have learned threads in Java, we will revisit this JVM and we will understand this red modules. So let's just focus on the yellow modules for this tutorial. First, let us understand with class loader. In class loader, what it does? So the byte code, it is given to the class loader. Now from this byte code, the static variables, access specifiers, name of class, okay, these all informations are loaded on method area of JVM. So JVM memory, you have a something called as a memory type, which is method area. On that you load static variables, access specifier and name of class, and there are some other information also you load. So when we say as class name, it will be first code. When we say as access specifier, example of that will be this public, and when we say static variables, so static int a equal to 0. So these are three components that are loaded on the method area: class name, static variables and access specifier. Okay. Now next step that happens on the class loader is object is being created. Okay. Now what is this object? don't worry about it now, you will learn that also concept further in your course. An object is being created of type object in stack area of JVM memory. Okay. When I say this, it means that a object is being created of type object. Type is object. Okay. O equal to new first quote. So, this is an object. This is how we create an object in Java. Okay. This line of code, a object is being created of type object in the which memory? Stack memory. Okay. In the when it happens in the step of class loader. Okay. So, when I say stack memory, you can say that this is stack memory. In this memory, a object will be created as O. Okay. And to what does it will refer? It will refer to dot class file, the dot class file or the bytecode, right, that you have, that will be stored on the heap memory, and this object will refer to that bytecode on the heap memory. Understood? So, the third line is the same. The object created points to dot class file or the bytecode in the heap memory. Next is, on this object you have a get class method with the help of which you can access different information about your class. So, let us check that also. So, if I do sys out, our object, right, dot get class, this get class has different methods like get name. So, to access different kind of information about your class. Let's clear this and save and run. So, you see you are getting a name of your class along with the package name. Next is we have something called as bytecode verifier. So, when all this operation inside class loader is completed, what the bytecode verifier does is it verifies your bytecode, the bytecode that you have given to your class loader. It will verify that bytecode against any errors, or it will check the correctness of your bytecode. Once the bytecode verification is done, the static variables and the method variables, any variables that you declare inside a method is called as method variables, both of them are being now initialized to their default value. Let us understand that too. So, if you are creating a variable inside it, int a equal to 5. Okay. So, when does this piece of code gets executed? Once the bytecode verification is done, then what happens is this a will be over here and the stack memory, it will point to a value 5 on the heap memory. Understood? Now, let us understand about JVM memory. Inside JVM memory, the first memory is method area. In method area, what will store? Class name, that we have seen how do we access it using dot get class method of object class. Then we have method informations, all types of variable informations, only the informations are being stored about the classes, methods, variables, the static variables. From variables, only the static variables are being stored on the method area, and this method area is a shared area. So, it is only one per JVM. Next is the stack memory. So, in stack memory what we store? Local method variables, like we have seen when we create a variable using int a equal to 5, right. This one int a equal to 5, it was stored where? On the stack memory, and the value was referenced to the heap memory. It will also store the object reference, which you have already seen. The O was stored on the stack memory, and it refers to the, it was pointing or it was linked to a dot class file or bytecode which was there on your heap memory. it is one per thread. Okay, what do you mean by one per thread? Threads are nothing but a large Java programs are divided or broken into small chunks of program, which is called as threads, and this is like one per thread. So if you have 10 thread in your program, each thread will have their own stack memory in the JVM, and this kind of threads memory, which is stack, it is called as record or stack frame. Next type of memory is heap memory. In heap memory, what you store? Object, and this is also one per JVM. Okay, so we have seen three memories: method area, stack and heap. So stack is only the one which is one per thread, called as record or stack memory, and the other two, method area and heap, are one per JVM. So they are called as shared memory. Now let us move to the third layer, which is execution engine. In execution engine, what it does? It will read your bytecode line by line and uses the variables, methods, values that you have stored in your different memory area of JVM, such as method area or the stack area or the heap area, and then it will give you an output. The work of execution engine is that. So how does the execution engine gives you output? First is, inside execution engine we have something called as interpreter. Interpreter is what? It will compile your code line by line, right? So it interprets the bytecode line by line and then executes your bytecode. That disadvantage of using interpreter is what? If you have a method, okay, then the interpreter does what is? It will interpret it line by line, right, and then give you an output. So if you are calling that method 10 times, the interpreter has to interpret that method 10 times, right? So it will slow your process of getting the output. So to overcome this kind of scenario, in Java we have something called as JIT, just in time compiler. So in Java you have both interpreter and compiler. So this compiler does is what? Like it will compile whole of your code in one go and store that native code. Native code is machine code or binary code in the form of 0 and 1. So it does what is? It will compile whole code in one go and store it. Anytime a method is being called again and again, JIT compiler will give that bytecode of that method which is being called again and again to the interpreter, okay, and then the execution of your Java code is faster. So inside JVM we have both interpreter as well as compiler. The third and the last inside execution engine is garbage collector. So all the methods or all the objects that you declare, that will be removed from all kind of memory inside JVM. The static variables from the method area, the variables, method label variables from the stack, or the object references from the stack, the objects from the memory which is heap memory, all of this will be removed with the help of garbage collector. So it will remove all unused object. Moving forward in your course, there will be a tutorial especially on the garbage collector. There is a lot that you will need to learn about the garbage collection in Java. We will see that when we will proceed further in your course. So that's all for this tutorial. In the next tutorial, you will learn about features of Java, advantage and disadvantages of Java. So if you have liked this video, do give a like, subscribe to my channel and do share with your friends. Thank you.